So this will be the first of the set of videos we'll be watching for this class. And so this one will cover sections 2.1 to 2.3 out of the book. And so have in terms of given a curve, so let's say we have our quadratic curve, which looks something like this. So this is the equation, y equals x squared. And we want to find the tangent to the curve at a given point. Now let's say we want to find it when x is equal to 2. So I got that x is 2. I know that the corresponding y value here is going to be 4. And we want the equation of what would be the slope of that tangent line to the curve at that given point. Well, so you learned before that in order to find slope, we need 2 points. So if I want to find the slope, I need to have 2 points. And so you learned before that in terms of slope, that slope was given by y2 minus y1 over x2 minus x1. So the change in y over the change in x. So if I want to find the slope, add 2. So let's start by taking the points x equals 2. And the other point we're going to use is when x is 3. So when x is 2, we got that y is 4. And when x is 3, we got that y is going to be 9. So the slope, then, is going to be 9 minus 4 over 3 minus 2, and this comes out to be 5. But let's say I want to get a better value as to what the slope is exactly at 2. So let's pick a point that's closer to 2. So now let's use that x is 2 and y is 2.5. Well, again, y is 4. But here, the new y value is going to be 6.25. And so now my new value for slope is going to be 6.25 minus 4 over 2.5 minus 2. And that gives us a value now of 4.5 for the slope. Right. So if I do another set of points, so making the difference in between my two x's even smaller, so let's use x is 2, and y is now 2.1. Sorry, x is 2.1, my other value. Well, again, the y value here is 4. The y value for this becomes 4.41. And we can do a slope again. Again. All right. We want the slope. Try a different color. There we go. That's better. The slope is going to be 4.41 minus 4 over 2.1 minus 2. And now we get a value of 4. Right? And now lastly, if I do one more point in this process, and we got x is 2, and now 2.01. Again, the y value here is 4. The new y value here is going to be 4.0401. And now if I do my slope for this side, we get 4.0401 minus 4 over 2.01. And now we end up with a value of 4.01. So we notice that as we get closer and closer to 2, that my slope is changing, and this number tends to be heading towards a value, okay? So the slope at 2, at x equals 2, is heading towards 4, right? So my slope at my particular x value is going to be 4. So we know the slope. So now I want to find the equation of that tangent line. So we want to find the equation of the line. So the equation of the tangent line and so for that you have that y minus y1 equals mx minus x1. That was called the point slope form. And when it was in this form, m represented the slope, and x1, y1 represented the point. So we know the slope is 4. We know the point is 2, 4. And so we can take those numbers and plug them in. Y minus 4 equals 4, x minus 2. So this is the x1, this is the y1. So that would be my equation in point slope form. And then if I wanted to put this into the other form, which was slope intercept form, and so slope intercept form was this, mx plus b form. And so if I rearrange this, we get y minus 4 equals 4x minus 8. Bring the 4 over. And we end up with y equals 4x minus 4. And that is the equation of the tangent line in slope intercept. So we have in terms of that. Well, velocity is given to be the change in distance divided by the change in time. So if I have a position function, s sub t is given by 4.9 t squared. Okay. So s is the distance, t is the time. Okay. And I want to know what is the average velocity at t equals 6. So I want to know what's the average velocity of this object when t is 6 seconds. Right? The way this equation actually is for an object that's just dropping in gravitational field. And so we want to find what's the velocity at a given time frame. Right? So we can again go through the same thing. I know that when t is equal to 6, that s is going to be 176.4. And then we also know that when t is 7, we can plug that into that equation, we get that s is going to be 240.1. Okay? And again, we can now find average velocity because we now have 2 points. So we can calculate this out. So we have that the velocity will be 240.1 minus 176.4 over 7 minus 6. And we get this comes out to be 63.7. But again, we go through the same steps we did in terms of the previous problem, that we make the time difference in between my two smaller. And so now let's go to the t is going to be 6.01, just to get through the process a little quicker here. We get that s now is going to be 176.98849. And so we end up with the velocity be 176.98849 minus 176.4 over 6.01 minus 6. And we get this comes out to be 58.849. And if we keep this process going, we'll find out that my velocity is heading towards 58.8. So if I keep on going, and if I do 6.0001, I get even closer, and so on. So we're heading towards that number. So we have in terms of finding slope, whether we're talking about in terms of change in y, change in x, or velocity, which is also a slope, because again, it's change in distance over change in time. We also think in terms of functions. We can look in terms of what's something that is called the limit of the function. And so you've got a limit in terms of the mathematics limit as x goes to some number a, whatever that is, of f of x. We're heading towards some value, whatever that is. That's what the L stands for. So basically this says that the limit of f of x is equal to L as x and I'm going to say x approaches, let's change that, as x approaches a. We're heading towards a number. So again, we go back to like what we had here. Yeah, we wanted a number at 6, and we said, okay, as I get closer and closer and closer to 6, my number is we're closing in on a value, whatever that may be, right? So that's basically what we're doing here. We're saying we're getting closer to a number as we get nearer and nearer to that number. So let's look at an example. So what is the limit as x approaches 1 of x minus 1 over x squared minus 1? Well, you'll notice if I actually plug 1 in here, this goes to 0, and that's undefined, right? So we got to say, okay, so we want to look at what happens as we get close to 1. So let's first start with numbers that are greater than 1. So let's start with numbers a little bit bigger than 1. Right? So we got that, and we'll make a little chart. And so for numbers 1.5, 1.1, 1.01, 1.001, and then 1.001. Right? So if I take these numbers and I plug them into there, so you take those numbers, you can plug them into your calculator. You get that this first one comes out to be 0.4. The next one comes out to be 0.476190. The next one is 0.477512. 1.001. We're down to 0.499750. And then the last one, we got 0.499975. So it looks like, at least going on this side of the world, we're heading towards a number, and that number seems to be we're heading towards 0.5. Okay? Now what happens if I do it numbers that are less than 1? What do we do? Right? So now we're going to come in from the other direction. And so now we got 0.5, 0.9, 99, 0.999, and then 0.9. Right? So now we get here going in the other direction. 0.526316. The next one, 0.502, 5113. Next one is 0.512250. And the last one, 0.500025. Right? So again, if I come in this direction, it looks like we're heading towards exactly the same number. And so we're going to say here that the limit for this, right? So the limit as x approaches 1 of x minus 1 over x squared minus 1 is going to equal to 0.45. And that's the key thing here, is that when I come in from this direction and I come in from the other direction, in order to have a limit, I have to be closing on an a number. In this case, we're closing on the same value no matter which direction we come from, okay? So this does have a limit as x goes to 1. Well, you can also talk about what are called one-sided limits. And so you've got the limit as x approaches a from numbers that are greater than a. You could also have the limit as x approaches a, but from numbers that are smaller than a. And so we have what are called one-sided limits. And so let's look at this in terms of a graph of what's going on. So we'll come up with a quick graph here of all this. And so close point here, and that at 5, close point here, and open point. Okay. I want an open point here, okay? And this goes like this, and then it goes on like that, right? So I got a graph. And I'm going to look at what are called one-sided limits. So, for example, what is the limit as x approaches 2, but from numbers that are less than 2? So I'm going along this part of the curve, and I notice I'm getting closer and closer to a value of 3. Right? Now, what would be the limit as x approaches 2, but now from numbers that are greater than Well, now I'm coming in this way, and now that value is 1 off the graph, okay? So then you get to this next one, which is what is the limit as x approaches 2, okay? So now, if I come in from this direction, I'm approaching one value, which is 3. I come in from this direction, I'm approaching a different value, which is 1. And so here, this one does not exist. Again, in order for this one, you have to be approaching the same number, no matter which way you come in, all right? So you have that. You can also have limits that actually go off to infinity. So you can have the limit as x approaches a of x would equal infinity. And then of course you can have this other part of it which says that you could go to negative infinity. And an example of that would be something like this. What is the limit as x approaches 0 for 1 over x squared? Right? So as I get closer and closer to 0, this bottom number is getting smaller and smaller and smaller, and you will be heading towards infinity. Right? And then I can do the same thing, just change the sign on the top. As x goes to infinity of negative 1 over x squared, and this time we'd be going off to negative infinity. So we can have limits that go off to infinity. Right? So, but what happens in terms of graphs where you have asymptotes? So now we have a graph. We're going to have an asymptote line, so let's put that in here. And then we're going to have a curve that goes something like this. And then on this side goes something like that. Right? And let's say that this is the value 3 there. And so we have an equation that looks like this. Y equals 2x over x minus 3. So we notice if I come in this way, I'm going off to positive infinity. If I come in this way, we're going off to negative infinity. Let's change this curve a little bit. Not crossing my asymptote line. Right? And so we're going off to 2 different directions, depending on which way we come. Right? So then you get in terms of calculating limits and how we do that. And so for that, let me call this in. This table's in your book, and just pulling it up here and put in the notes. And so you got, these are the limit laws, which says, okay, if I'm adding, I can find the limit of the first part, get that number, and add it to the limit of the next part. And we'll go through these laws and how they're used. So let's go through a couple examples of exactly what this means, okay? It looks complicated on here, but when you do it, it's actually quite simple. So that's fine. We want to calculate the following limits. So we want to plug in, we're going to get some numbers here. So, for example, what is the limit as x approaches 2 for 2x squared plus 3x plus 3? Okay? So what all this says is what we can do is we can just take our number 2 and we can plug in. And so we would end up with 2 times 2 squared, 3 times 2, plus 3, and we find out we're heading towards 17. And a couple other examples of this, so let's look in terms of something like this. What is the limit as x approaches -3? And we got x squared, 7x plus 12 over x plus 3. Right? Well, this time you notice if I plug in -3, I got a problem, because -3 plus 3 is 0, and you can't divide by 0. But now you get to, in terms of this quadratic, that quadratic actually can be factored. If I factor this, I get x plus 4 times x plus 3 over dx plus 3. So now these go away, and now I'm left with something where I can plug in, and we find out here that this will come out to be 1. And then one more, and so we got this one, what is the limit as t approaches 9 of 9 minus t over 3 minus the square root of t, right? But again, if I plug in 9 in there, I got a problem because the bottom term will be 0. But this one, again, we can sort of, there's a little trick here in that I can factor. This, after all, if you remember from back in your other classes, is difference of squares. You know, it didn't quite look like it. But this top part can be rewritten as 3 plus the square root of t and 3 minus the square root of t over 3 minus. And then, of course, now that I turn it that way, we got that this and this goes. And now we can plug in. And so the square root of 9 is 3, and 3 plus 3, we end up with a value of 6. So you have, in terms of given a function, being able to find a limit. Okay? And if you can factor it and make it so you can plug in, like in these last couple. Okay? Otherwise, if you can't, then you go back to having to come up with a chart, and then calculating, and just see if, when you come in from both directions, do you approach a given number, then it has a limit. And with that, that will conclude the segment.